Hi everybody, I'm back. I know you missed me. Okay, we're still working with end behavior of our polynomial functions. Now, we have to be able to recognize what the end behavior is going to look like from any given quadratic, any given quartic, any polynomial function without necessarily graphing it. Now, when we have an x cubed, we'll start with cubic functions. So if I have an x cubed, okay, these three, there's three situations that can occur. So what can happen is in the first one, and these you can put right in your graph, okay? So there's something like this. Now, the things you should be able to identify, you should be able to identify what this is right here without even putting in the graph. This is going to be 8 because that is the y-intercept right here. So if I put 0 in, I get 8. Okay, it's not drawing a scale. I just did a quick sketch. Okay, now circle its x-intercept. So the 3 tells you that's the maximum number of zeros it can have. Okay, it can have 3 zeros, and there it is. Okay, now minimum, it has to have 1 because the end behavior goes in opposite directions for a cubic. So this is one thing that can happen, go through in 3 places. Next one, something like this. Okay, this again is 9. Here there's only 1 x-intercept. Okay, it can happen. You have 2 imaginaries and then 1 real. Now the third thing that can happen is, now look at this. There is no c. Okay, so that means that c is 0. So it has to go through the origin. And you can see all these if you put them in your graph paper or in your graph page of your calculator. Okay, this one comes up just like that. Okay, so there's that. And then this one here is what we call the double root. Okay, so it gives you a total of 3 zeros, but 1 is a double root. So those are the 3 scenarios that can happen. And of course, these are all positive x cubed, so that's why they go in that direction. If they were negative x cubed, remember they would go in the other direction. Okay, just as it ties with this. Okay, the x-intercepts, we talked about that. Okay, exercise 2, determine the zeros of the function. Now, you can use your calculator to help you. So if you pull up the calculator, okay, remember, you pull up the calculator, menu 3, what the heck happened? Okay, menu. Oh, something's going on here. Hold on. Let me see what's going on here. All right, maybe I was on the wrong page. Menu. Okay, now the degree from real to complex, you can change the degree. Okay, so it's a degree of 3. And then we have what? We have 1, and then -1, -12, and then 0. Okay, here we go. Let's find the roots. Enter, enter. -3, 0, 4. So what do we have? X equals -3, x equals 0, x equals 4. We've worked on before, this x equals 0 is just x. This x minus 3 is x plus 3, and the x equals 4 is x minus 4 equals 0. Okay, now if you took the original equation here, all right, you can see a GCF. So I take out an x, I have x squared minus x minus 12. Here's my x, and then the factors of 12 that give me -1 are x plus 3, x minus 4 equals 0. Okay, so there you have it. Now, sketch a graph of this. So it's 1, 2, -3, it's 0, 1, 2, 3, 4. Okay, so it goes right through the origin again. It's positive, so it's something like that. Okay, just a rough sketch. If you want a more accurate sketch, what do? You go to your graph, okay, and plug it right in. Okay, so a lot of calculator work, like we've talked about in class. Use your calculator where you can. Exercise 3, the largest root falls between what 2 consecutive integers? So menu 331, which I already showed you and we already know how to do, or you can graph it. So if you went to the graph page, okay, because some people, as we're doing these practice review packets, people are asking, can I do it this way? Of course, there's more than one way to do these problems. Okay, so I'm just plugging these in, plus 12x, and then plus 22. And you've seen some of the difficulty. We've seen some of the Regents questions. Some are pretty easy. And this one doesn't seem to be too bad. Okay? It says between what two consecutive integers does the largest root? So this is 10 here to the right. Okay? Right there. So that means 1, 2, 3, 4, 5, 6, 7, 8. It all goes up by ones. So that's between 6 and 7. Okay? Between 6 and 7, which is choice 2. Okay? Now, consider the quartic function. All right? Algebraically determine the x-intercepts of this function. So here we go again. Menu, let's go back here. Okay, menu, 3, 3, 1. The degree is 4 this time. Okay, a degree of 4. And we're going to hit OK. So my x to the fourth is 1. There is no x cubed, 0. X squared is negative 5. X to the first is 0. And the constant is 4. Okay? Negative 2, negative 1, 1, 2. Okay? So we have x equals negative 2, x equals negative 1, x equals 1, x equals 2. Okay? Now, as long as this goes down, okay, for 2, you can treat this as if it was an a squared minus 5a plus 4. As long as it goes down 4 and then to x to the fourth, x squared, and then x to the 0 power. Okay? And the only thing, so if I have this a1, it would be a minus 4, a minus 1. Okay? So since it's this process here, we're going to have x squared minus 4, x squared minus 1 equals 0, because we want to find the x-intercepts. And then difference of two squares, x plus 2, x minus 2, x plus 1, x minus 1. They all equal 0. And that's how you get all those values. Okay? Let me put some lines between these here. That's how you get them all. So the x plus 2 is right down here. That's the x minus 2. X plus 1 gives you that one. X minus 1 gives you that one. Okay? Verify your answers to part A by sketching a graph of the function on the axis below. Okay. Negative 2, negative 1, 1, 2. What is the y-intercept? Whoop, 4, somewhere around there. Okay. X to the fourth, it opens up, so it's going to be something like that. Okay, something like that. And of course, you go to the graph and you get a more accurate graph. Accurate. Okay. Consider the quartic whose equations is exercise 5. I know I'm going kind of quick here. Sketch the graph of this quartic on the axis below. Label the x-intercepts. Okay. Label the x-intercepts. So that means menu 3, 3, 1. A degree of 4. Okay. Now these are bigger numbers, so of course you're going to want to use your calculator here. So we have 1, 3, negative 35, negative 39, and 70. You don't want to factor this one. Okay. Enter. Negative 7, negative 2, 1, 5. Okay. Negative 7, negative 2, 1, 5. Okay. Y-intercept 70. So 500, 250, 70 is right about there. Negative 7, negative 2, 1, 5. X to the fourth, and behavior goes up. So here we are. Oh, should be through this point here. Okay. There they are. Label the x-intercepts. Label the x-intercepts. Negative 7, 0. -2, 0, 1, 0, 5, 0. Okay, you have to label where it says to. Based on your graph from part A, write the expression in its factored form. Okay, these are the zeros. So an expression, no y equals. Okay, we talked about function in the last lesson. We had to have the y equals. Okay, -7 is x plus 7. -2 is x plus 2. 1 is x minus 1. 5 is x minus 5. Okay, that is its factored form. Okay, kind of working backwards like we work on with the calculator. All right, so I think that's it. Look at how quick and easy, 10, 11 minutes, not a problem. Don't forget to work on your mid-review. Okay, the mid-course review, which is due Wednesday, March 4th, in the beginning of class. We'll see you in class.